welcome back to Calculus with Mr. Robeson. All right, so we learned to do implicit differentiation in the last one, so now we're going to apply it to finding tangent lines and slopes of tangent lines, and then we'll look at the second derivative implicitly, which is oh so much fun. All right, so find the equation of the tangent line implicitly, determine the slope of the graph of this guy at the point 3, 1. All right, so when we're finding the slope, oftentimes, we don't even want to solve for dy dx. We just want to take the derivative and plug in the numbers, right? Because this 3 is our x, and this 1 is our y. It will save us some simplifying, and we'll be working with numbers, which is usually preferred over working with variables. So if we want to take the derivative of this guy to find the slope, we need to do the chain rule here. So the 3 stays. We bring down the 2. That's going to be 6. We leave the inside the same, x squared plus y squared, to the 1 less exponent, so to the first, times the derivative of the inside. So the derivative of x squared is 2x. Derivative of y squared is 2y times dy dx, or we could say y prime, equals, all right, now over here, we've got to do a product rule, because we have x times y, so we'll put the 100 with the x, so it'd be 100x first, times derivative of the second, derivative of y is y prime, plus the second, times the derivative of 100x, which is just 100. All right, so there is our derivative implicitly. All right, now we are trying to find y prime when x is 3 and y is 1. So I'm going to go ahead and plug in 3 everywhere for x and 1 everywhere for y. So that means the only variable I'll have left is y prime, and that is our slope at that point. So if we plug in, we'll have 6 times 3 squared plus 1 squared, 2 times 3 plus 2 times 1 times y prime equals 100 times 3 times y prime plus 1 times 100. All right, so now we're just simplifying. So we get 6, 9 plus 1 is 10, 6 plus 2y prime equals 300 y prime plus 100. All right, so we're going to, let's see, that's going to be 60. We're going to need to distribute that. So 60 times 6 is 360. 60 times 2y prime is going to be 120 y prime equals 300 y prime plus 100. So we're going to subtract the 120 over here. That gets me, what, 180 y prime. Subtract the 100 over here. That gives me 260. And then divide by 180. All right, so we can cancel out the 0 there. We can also cancel out a 2 from both of those, and that's 13 over 9. All right, so that is our slope. All right, if we wanted to make the equation of the tangent line at that point, well, y minus our y value, 1, equals our slope times x minus our x value, 3. And there's our equation. All right, so we took the derivative implicitly, we plugged in for x and y, we solved for dy dx, which in this case is our slope, and then we plugged into the form to write out the equation. All right, and if you're curious, that's what the graph looks like. That's called a lemniscate. It's like an infinity sign, kind of twisted a little bit. Cool, huh? All right, another example. So again, we're going to follow the steps. We're going to take our derivative implicitly. This time we want just the equation of the tangent line. So remember, again, whenever we see tangent line, that means derivative. All right, so we need to take the derivative of this guy at the point 1, 3. So we need the point, which we already have, and we need the slope. So we're going to take the derivative to find the slope. So I'm going to rewrite this as x plus y to the 1/2. And here I've got x times y squared, so that's going to be a product rule. So here we're doing a chain rule, so that would be 1/2 x plus y to the negative 1/2 times the derivative of the inside. Derivative of x is 1. Derivative of y is y prime, or dy dx, equals, now we're doing a product rule here, so it's first times the derivative of the second, so 2y times y prime, there's a chain rule happening there, plus the second, y squared, times the derivative of the first, derivative of x is just 1, minus derivative of 7 is 0, so I'm not even going to write it. It's gone. Now I can try and solve for y prime, or I can plug in. So my x here is 1, my y here is 3. It's kind of reverse from what we had last time. I'm just going to plug in. All right. So I believe that is the next step. Yep, plug in for x and y. So we get 1/2, 1 plus 3 to the negative 1/2, 1 plus y prime equals 1 times 2 times 3 times y prime plus, let's see, 3 squared times 1, so just 3 squared. So now we're simplifying. So we get 1/2. This is going to be 1 over the square root of 4. And this is 1 plus y prime still. 1 times 2 times 3 is 6 y primes plus 9. All right, square root of 4 here is 2. So 1/2 times 1/2 is 1/4. So if we could distribute that, or we could just multiply the other side by 4, multiply both sides by 4 to cancel that out. So this is going to cancel out that. We're left with 1 plus y prime equals 24 y prime plus 36. So that multiplying by 4 got rid of my fractions for me. I know some of you don't like fractions so much out there. So we're going to subtract y prime here. We get 23 y primes. We're going to subtract 36 from here. We're going to get negative 35. And we're going to divide both sides by 23. And we get that our y prime, which is our slope, is negative 35 over 23. All right, so I just made up this number, this problem up here, so it's not surprising that we got something strange. So we solved for our dy dx, or solve for our y prime. There's our slope. And now we need to plug into our form. So we get y minus 3 equals negative 35 over 23, x minus 1. And there's our line. Fun times. All right, here's an example. Give it a try. So we want the equation of the tangent line to that curve at the point 2, 1. All right, hopefully you stopped this and gave it a shot. So we're going to have to do a product rule here. Everywhere else we should be okay. So product rule here, it's first times derivative of y, which is y prime, plus the second times derivative of x squared, which is 2x. So there's our product rule. Now we're derivative of this guy. We bring down the 2. 4 times 2 is 8. Y to the first times derivative of y is another y prime equals derivative of 8 is 0. Now instead of trying to solve for y prime, we're going to plug in our numbers for x and y. So x is 2, y is 1. So we get 4y prime plus 1 times 2 times 2, so plus 4, plus 8 times 1 is 8, y prime equals 0. So we got 12y primes. We're going to subtract the 4 over, equals negative 4. Divide by 12. We get negative 4 over 12, which we can leave like that, or we can say is 1/3 if we reduce that. So we got negative 1/3 for our slope. So that means our line is y minus our y value, 1, equals negative 1/3 x minus our x value, 2. Right, looks like that's it right down there. Yep, that's it. All right, second derivatives. Oh boy. So we know how to find the first derivative. Right, there's a little trick though when it comes to finding the second derivative. So the first thing we do to find the second derivative, and this is the notation for the second derivative. So second derivative notation right there, d squared y dx squared. So we take our derivative normally, 2x plus 2y times y prime equals, derivative of 25 is 0. All right, we're going to subtract the 2x because we want to solve for y prime. We want everything with y prime on one side, everything without it on the other. So we get negative 2x over there. Divide by the 2y here. Oops, left off my prime. Y prime equals negative 2x over 2y. 2's can cancel out here. And we get y prime equals negative x over y. Well, cool, but that's just dy dx, and we want the second derivative. So we need to take a derivative of this. So We take derivative of this side, we get y double prime. Take derivative here, we're using the quotient rule. So the quotient rule says low d high minus high d low, derivative of y is y prime, over bottom squared. Square the bottom and away we go. All right, so now, let's see, we got a negative and a negative. Those will cancel out. But we still have a derivative here. We don't want to leave a derivative in this answer. So what we do is we go back to this line and we say, well, y prime is negative x over y, and we plug that in here. This ends up happening an awful lot when we do second derivatives. We get the first derivative as some part of our answer. So that's negative y plus x times, and we just take what it was equal to and plug it back in. Negative x over y all over y squared, and now it's just a matter of trying to make it look pretty. Y prime, double prime, sorry, equals, well, we can get a common denominator here, so this would be times y over y. So we'd have negative y squared minus x squared all over this y, which will move down to the bottom. So it's going to be all over y to the third. We can leave it like that if we want, or we can pull out a negative if we want. There's really plenty of things we could do. We can pull out a negative, and we'd have x squared plus y squared on top over y to the third. And now here's something really cheeky we can do. If we look back at the beginning here, x squared plus y squared for our equation is always equal to 25. So that means this is actually just 25. So we could say it's negative 25 over y to the third like that. Sneaky, huh? All right, so sometimes they do that when we write answers, and it's just a matter of trying to find the right way to match what they have for answers. If it's multiple choice, if it's free response, this is probably a fine answer, or this, or even this right here is correct. All right, the second guy. So now we've got a trig function in here. All right, doesn't make any difference. We still just do it the same way as before. So we take a derivative here implicitly because we can't solve for y. Derivative of y is y prime. Derivative of x is 1. Derivative sign is cosine, so cosine of y, times the derivative of the inside, which gives us another y prime. So we subtract this guy over. We want to get all of our y primes together. Or we can subtract this guy over and then subtract that guy over. But it's probably easier just to move this one. So if we do that, we get y prime minus cosine of y times y prime equals 1. Now this is not inside the cosine. This is outside the cosine. So we get y prime 1 minus cosine of y equals 1. Go ahead and divide by that. We get y prime equals 1 over 1 minus cosine of y. So there's our first derivative. We want to find our second derivative. All right, so we have a constant on the top and a variable on the bottom. We learned it last section with the chain rule. We could rewrite this as 1 minus cosine of y to the negative 1, and now just take this derivative as a chain rule instead of having to do a quotient rule. So if we do that as a chain rule, we get over here the derivative of y prime is y double prime. Bring down our negative 1. We got 1 minus cosine of y, inside unchanged, to the 1 less exponent, negative 2, times the derivative of the inside. Well, the derivative of 1 is 0. We got negative. Derivative of cosine is negative sine of y, times the derivative of the inside, so times the derivative of y, which is another y prime. All right, these two negatives are going to cancel out here. This guy can move down to the bottom, so we'll get y double prime equals negative 1 times sine of y times y prime all over 1 minus cosine of y squared. All right, now we're going to do the same trick we did before. We're going to get rid of this y prime by saying y prime is just equal to that. So this is negative, I don't need to write negative 1, I can just write negative sine of y times 1 over 1 minus cosine of y all over 1 minus cosine of y squared. All right, so now 1 minus cosine of y here, we got two more of them down here. This one can move down with that. So we end up getting y double prime equals negative sine of y over 1 minus cosine of y. We had 2 plus 1 more, so to the third, like that. All right, I don't see any tricky things we could do with this one like we did with the last one, so that's just our answer right there. A lot of work there, I know. All right, last one, I think. So example, give it a try. Find the second derivative implicitly. All right, so if I was to do this, let's see, we've got this x times y here. We're going to do that implicitly. We've got a negative sign in front. Derivative of 1 is 0 minus first times derivative of the second plus the second times derivative of the first, which is just 1. Derivative of 2x is 2. Derivative of 3y is 3y prime. So distribute the negative here. We'll have negative x y prime minus y equals 2 minus 3y prime. Now we want all of our y primes on one side, so I'm going to add the 3y prime over here. We'll have 3y prime minus xy prime, and I'm going to add the y over here. Like that. We're going to divide out the y prime, or factor out the y prime. We're left with that. We can now divide. We get y prime equals 2 plus y over 3 minus x. All right, so there's our first derivative, but we want our second derivative. So now to get our second derivative, we've got x's on the bottom, y's on the top. We need to do a quotient rule. So to get our second derivative, y double prime, doing a quotient rule. So it's low d high. Well, derivative of 2 is 0. Derivative of y is y prime minus high times d low. Derivative of 3 is 0. Derivative of negative x is just negative 1. All over the bottom squared. All right. We do have a y prime here, so I'm going to take what y prime was equal to, and I'm going to plug it in for y prime right there. All right, so we're going to get y double prime is 3 minus x times 2 plus y over 3 minus x plus, let's see, these two negatives are going to cancel out, give us a plus. So plus 2 plus y all over 3 minus x squared. We can't bring this down, but we can cancel those out. So we get 2 plus y plus 2 plus y, so that's 4 plus 2y over 3 minus x quantity squared. And that looks like answer choice A. All right, so that's it for implicit differentiation. I know this is a little tricky, but it just takes some practice. Remember, just take derivatives normally. X and y are both variables. Whenever you have y and you take its derivative, you get a dy dx or a y prime. All right, so we looked at tangent line equations and finding second derivatives here. There will be practice exercises now on Google Classroom, and they will be due next class.